upgrade or other beneficial changes which, without this kind of documentary support, might otherwise be rejected or, at best, accepted very slowly.
A new land application program at Charleston is a case in point. State regulators readily accepted the idea based on pilot testing in which iron replaced aluminum as a coagulant. A 37-acre wooded area adjacent to the Hanahan water treatment plant has been subsequently laced with a network of pipes and spray columns to dispose of the sludge in a program expected to result in significant savings. The land application program is only the latest in a series of process technologies involving the use of the pilot plant to optimize Hanahan's performance. At Myrtle Beach, iron replaced alum as a coagulant in water treatment in January of 1995. This, again, was a measure taken following pilot testing of alternatives. Following the changeover, settled water quality improved dramatically, reducing the dosage and cost of ozone, according to Ted Welch, treatment facility manager. Mr. Welch, describing numerous improvements and substantial cost savings resulting from pilot plant studies, sums up the facility's benefits. Mr. Welch.
This is a rather high dollar investment here, a rather high dollar expense. And by utilizing the pilot plant to optimize our treatment processes, we have seen a substantial reduction in our use of ozone, which directly translates out into lower electricity costs and, in turn, lower O&M costs.
Instrumentation is critical in the performance of a pilot plant, just as it is in full-sized facilities. Two traditional instruments, a turbidimeter and head loss gauge, are complemented by state-of-the-art laser particle counters. These devices are installed in the raw, settled, and filtered water lines, where they help predict full-scale plant responses to treatment changes. Doug Waldrop, Water Resources Manager of the Spartanburg Water System, describes the location and importance of particle counters, both in his pilot testing and in the water treatment plant. Mr. Waldrop.
One of the major issues facing the water industry today is organisms such as Giardia and Cryptosporidium. One of the ways that water treatment technology is coping with that is to determine the size of particles that our filtering system is taking out. This is one of our particle counters. We have one on each of the filter columns, plus one on the settled water coming into the filters, and also we measure the particle count on the raw water coming into the treatment facility itself. The particle counters pass a sample of the water through a laser light that in turn measures the particles in that sample of water. That information is recorded into the bit logger and is available for us through a PC network.
It takes about 6 months to design, assemble, and start up the modular components of a pilot plant. The pilot plant typically has 2 side-by-side trains. These 2 treatment lines facilitate comparison studies between alternative treatment concepts. Modular construction of components, such as filter columns, make the pilot plant easy to assemble and move. Acrylic specialists in Atlanta fabricate the modules. Assembly of the modules can be completed by the owner's staff or by Jordan Jones and Golding specialists. These are modules for the new Macon pilot plant, which, for the time being, are located in a part of an existing water treatment plant scheduled to be replaced by the newly designed facility. As the new plant is being designed and built, the pilot plant will be evaluating various coagulants and disinfectants for use in treating water from the Ocmulgee River. Pilot plant modules, each equipped with casters for mobility, correspond to specific processes within a full-size treatment plant. Major components include the raw water intake and delivery module, a flash mixing tank in which chemical coagulants are mixed with raw water. Next in line, flocculation basins. In this case, there are 4 in each line, each with its own internal agitator, maximizing flocculation efficiency. Sedimentation tanks utilize plate settlers and innovative sludge collectors to aid in the removal of collected sludge. A settled water tank which receives water from the sedimentation basins from which it flows into filters. filter columns. This pilot plant has an ozone module with a generator, monitor, and test columns to evaluate the oxidant's benefit at different points in the treatment process. The pilot plant is an excellent training platform. Its various see-through clear lucite modules enable technicians to witness firsthand how components in a treatment plant perform. Understanding the pilot plant's chemical feed process requires that operators be familiar with the controls which automatically add coagulant chemicals, such as ferric sulfate, alum, or ferric chloride to incoming raw water. The chemical efficiency is a function of the treated water pH, which is also monitored at this station. Some of these scenes were taped at the Spartanburg plant following a tropical storm which dumped up to 13 inches of rain in the region. Considerable flooding resulted. Contrary to the pristine condition of the water in Lake Blaylock, which was shown earlier, this scene, Lake Blaylock became highly turbid. This high turbidity is obvious here in the flocculation basins of the pilot plant, which handled the adverse conditions very well. One of the best illustrations of a treatment plant in action occurs in the sedimentation basin. The sedimentation process is clearly visible in this chamber, giving the operators a well-founded understanding of what actually goes on in the treatment plant itself. The ozone generator and monitor are self-contained units which perform just like the full-scale equipment, producing ozone which oxidizes compounds in the water. Pilot plants have multiple filter columns in which settled water can be filtered through various combinations of media. Test filters include typical sand and anthracite media, but may also include granular activated carbon and garnet. Various combinations of these media can be evaluated side by side to determine the optimal design. The pilot plant can reproduce all of the processes of a treatment plant right down to filter backwashing. This filter column is undergoing air-supplemented backwashing, which simulates action in a recently renovated filter in the Charleston treatment plant. As we have seen, the uses of a pilot plant are varied, from increasing water plant productivity to improving operator training, and all the while helping to improve water quality. A quarter of a century ago, we had to look out for only a handful of harmful compounds in our water supply. Today, we know of at least 180 of these harmful compounds and must design, build, and operate our water treatment plants accordingly. At the same time, we are urged to high-rate our treatment facilities to meet growing consumer needs for water. Jordan Jones and Golding is pleased to have joined over 100 communities in solving their water resource needs and improving water quality, doing so by designing treatment facilities which boost productivity, comply with the most rigid regulations, and which instill public confidence in this most vital resource, our water.